Hi, welcome back to my class in Calculus 3. For today, we will take up polar coordinates. Polar coordinates is similar to rectangular coordinates. In rectangular coordinates, a point has two coordinates, the abscissa x and the ordinate y. In polar coordinate, a point has also two coordinates. The first coordinate is known as the radial coordinate and is denoted by r, while the second coordinate is known as the angular coordinate and denoted by angle theta. A point in polar coordinate has two coordinates denoted by r theta. Always we start with the radial coordinate denoted by r, followed by the angular coordinate denoted by theta. Now the radial coordinate is actually referring to the radius vector, which is the distance of the point from the origin. And the angular coordinate is an angle that may be expressed either in degrees or in radians. And we plot these polar coordinates of a point in two-dimensional space. The polar coordinates consist of concentric circles. All these circles have the same center at the origin. And the origin is now known as the pole. And the horizontal axis is the polar axis. A polar axis is a ray that originates from the pole, which is the origin. And any point in this polar coordinate has two coordinates, the radial coordinates, which is the distance of the point from the origin. The radius of this circle is 1 unit, the radius of this circle is 2 units, and this one is 3 units. So from the origin to this point is 3 units. And these circles are concentric circles because they have the same center. And angular coordinate theta, which is expressed either in degrees or radian, is an angle in standard position. An angle in standard position has a vertex at the origin, now known as the pole. And the angle in standard position theta is measured in counterclockwise direction, always beginning from the positive x-axis or this horizontal axis, the ray to the right of the origin. So for the angular coordinate, we measure an angle with vertex at the origin with initial sign on the positive x-axis or this ray to the right of the origin, moving in counterclockwise direction. And after measuring that angle, we measure our units from the origin for the radial coordinate of the point. We now take an example We now take examples of how we plot points in polar coordinate. Examples, plot the points number 1 to 30 degrees. In this point, the radial coordinate is 2 units. And the angle theta is given in degrees. Theta is 30 degrees, the angular coordinate. And to plot this point, we always start with the angular coordinate 30 degrees. And 30 degrees is taken as an angle in standard position. Thus, its vertex is at the origin or the pole. And the initial side of 30 degrees is the ray to the right of the pole or the positive x-axis. And from the positive x-axis, we measure 30 degrees in counterclockwise direction. And I will now approximate 30 degrees from the positive x-axis. From the positive x-axis or the ray to the right of the pole, we measure 30 degrees counterclockwise. So this angle from this point up to this point on this terminal side of 30 degrees is 30 degrees. Now after measuring 30 degrees, you measure 2 units from the origin. From the origin, this is 1 unit and then 2 units. And this is the point with polar coordinates 2, 30 degrees. Number 2, we plot the point with coordinates 3, pi over 6. In this point, the radial coordinate r is 3 units. And the angular coordinate theta is pi over 6. Now theta is given in radians. But radians can always be converted to degrees by taking pi equals 180 degrees. If pi is equal to 180 degrees, we replace pi with 180 degrees and we get 180 degrees divided by 6, we get 30 degrees. Hence, this point is the same as 30 degrees. Again, we measure 30 degrees from the positive x-axis or from the ray to the right of the pole. And this is 30 degrees. And from the origin, we measure 3 units. From the origin, we measure 3 units on the terminal side of 30 degrees. This is 1 unit, 2 units, 3 units. And this is the point with polar coordinates 3 and pi over 6. Next, we plot the point negative 1, pi over 4. In this example number 3, the radial coordinate is negative 3. In example 3, the radial coordinate is negative 1. Now, the radius vector or the radial coordinate is always positive. But in this case, the negative sign here indicates the direction of the radius. This means that when you plot the radial coordinate, you count 1 unit on the opposite side of the opposite the terminal side of pi over 4. And again, the angular coordinate is given in radians, and we convert it to degrees by taking pi equals 180 degrees. If pi equals 180 degrees, we get 180 degrees divided by 4. That gives us 45 degrees. And we start by measuring 45 degrees from the positive x-axis or the ray to the right of the pole. I will now approximate 45 degrees. From this point on the initial side of 45 degrees to this point on the terminal side, this is the terminal side of 45 degrees. This angle is 45 degrees measured in counterclockwise direction. Now, if the radial coordinate is positive 1, we measure 1 unit from 0 and we count 1 unit. And the point is here, the point with coordinates 1 and pi over 4. But the given radial coordinate is negative 1. That means we measure 1 unit on the ray opposite the terminal side of 45 degrees. So this is just the extension of the terminal side of 45 degrees. And from the origin you count 1 unit and you will land at this point. From the origin you count 1 unit on the ray opposite the terminal side of 45 degrees. And this is the given point, negative 1 pi over 4. Now we find the way of converting a point with Cartesian coordinates x and y to a point with polar coordinates r and theta, and vice versa. We want to find the Cartesian coordinates of the polar coordinates of the point with polar coordinates r, theta. And vice versa, we will find a way to find the polar coordinates of the point with Cartesian coordinates x, y. We start by plotting this point. Again, theta is the angular coordinate, and this is the angle in standard position with vertex at the origin, and measured from the ray to the right of the pole or from the positive x-axis in counterclockwise direction. I will just approximate theta. This is the angular coordinate of the point r theta, and from the origin we count r units. This is the radial coordinate of the point r theta. And this is the point with polar coordinates r theta, and we want to take this point, this same point as the point with Cartesian coordinates x, y. If this point is the point with these polar coordinates and this point is the same point with Cartesian coordinates x, y, we construct a right triangle by projecting this point down to the positive x-axis, perpendicular to the positive x-axis. And if this point has Cartesian coordinates x, y, the distance of this point from the horizontal axis or the x-axis is x units. Again, if this point has Cartesian coordinates, the distance of this point from the horizontal axis or x-axis is y units. And the distance of this point from the vertical axis or y-axis, which is equal to this leg of the right triangle, is x units. And the distance of this same point with Cartesian coordinates x and y is the distance of the point from the origin, denoted by r, and is known as the radius vector, and is also known as the radial coordinate of this point with polar coordinates r theta. And from this right triangle, we find the cosine of theta. Cosine of theta is defined as the ratio of the side adjacent to theta over the hypotenuse. And the side adjacent to theta, or the side of the right triangle that makes the angle theta with the hypotenuse, is x. And the hypotenuse is the side opposite the right angle, which is equal to r. And multiplying r, the radius vector or the radial coordinate, by cosine theta, you get x equals r multiplied by cosine theta. And this is the equation that you will use to find the abscissa of the point with polar coordinates r theta. Now we also write the value of sine theta. Sine theta is equal to the ratio, the value of sine theta is equal to the ratio of the side opposite theta and the hypotenuse. From the diagram, the side opposite theta is y, and the hypotenuse is the side opposite the right angle, which is equal to r. And this is the equation that you will use to find the ordinate y of the point with given polar coordinates. If you are given the polar coordinates of a point and you want to find the point with Cartesian coordinates, the abscissa of that point with Cartesian coordinate is given by r multiplied by cosine theta. The given here are the radial coordinate and the angular coordinate of the point with polar coordinates. And the ordinate y, the second coordinate of the point with Cartesian coordinate, can be found using this equation. The given again are the radial coordinate r and the angular coordinate theta of the point with polar coordinates. Now, if you are given the Cartesian coordinate and you want to find the point, the same point in polar coordinates, you have to find the radius and the angle theta. And you find the angle theta using the tangent function. The value of the angle, the acute angle theta of right triangle is equal to the ratio of the side opposite the angle theta and the side adjacent to the angle theta. From the diagram, the side opposite the angle theta is y. Divide by the side adjacent to the angle theta. Adjacent side is the side of the right triangle that makes the angle, the acute angle theta with the hypotenuse. And the adjacent side has a length of x units. And this is the formula that you will use to find the angular coordinate of the point with polar coordinates. The angular coordinate is given by shift tangent or inverse tangent or arc tangent of y over x, which is obtained from tangent equals y over x. And finally, we find an equation to find the radial coordinate, and we find the radial coordinate by simply using the Pythagorean theorem. And the Pythagorean theorem says that the square of the hypotenuse is equal to the sum of the squares of the legs of the right triangle. The legs of the right triangle are the opposite side, the side opposite the angle theta, and the side adjacent to angle theta with lengths of x and y. And the hypotenuse is the side opposite the right angle with the length of r. So by Pythagorean theorem, the square of the hypotenuse, r square, is equal to the sum of the squares of the legs of the right triangle, x and y. Another way to find an equation for calculating r is to calculate the sum of the squares of x and y. x is equal to, we will simplify and find the value of the sum of the squares of the legs of the right triangle. X is equal to r cosine theta. So we replace x with r cosine theta and we take the square. Y is equal to r sine theta. So we replace y with r cosine theta and we take its square. And applying property of exponent, the square of r cosine theta is equal to r squared multiplied by the square of cosine theta, which is cosine squared theta. And again, by applying one property of exponent, the square of r sine theta is equal to the square of r squared multiplied by the square of cosine by the square of sine theta, which is equal to sine squared theta. And by inspection of the sum at the right hand side, you can see that there is a common factor, r squared. We factor out r squared from the right. If we factor out r squared from the right, we get r squared times quantity cosine squared theta plus sine squared theta. That is, r squared is the common factor, and to get the other factor, we divide each term of this sum by r squared. R squared cosine squared theta divided by r squared is equal to cosine squared theta plus r squared sine squared theta divided by r squared is equal to sine squared theta. But from your course in trigonometry, plane trigonometry, the sum of the square of cosine squared theta, the sum of the square of cosine theta and the square of sine theta is equal to 1, and that is one of the three Pythagorean identities. One of the Pythagorean identities says that the sum of the square of sine plus the square of cosine is equal to 1. So we replace cosine squared theta plus sine squared theta with 1 multiplied by r squared is equal to r squared. Thus we have derived a way to find the radial coordinate of a point given its Cartesian coordinate. This means this tells us that the square of the radial coordinate of the point is equal to the sum of the square of the abscissa of the Cartesian coordinate of the point and the square of the ordinate of the Cartesian coordinate of the point. We will now take some examples. We now take some examples of converting a point with the given Cartesian coordinates to a point with polar coordinates. Examples: find the polar coordinates of each. Number 1, the point with Cartesian coordinates -4, 2. And our objective is to find the point with polar coordinates. Our objective is to find the point with polar coordinates given the Cartesian coordinates of the point. It means the Cartesian coordinates of the point, then x equals -4 and y equals 2. And we start by finding the radial coordinate of the point R using the Pythagorean theorem. the square of r is equal to the sum of the squares of x and y. Using the Pythagorean theorem, the square of the radius vector is equal to the sum of the squares of the abscissa and the ordinates of the point with the given Cartesian coordinates. So replacing x with -4, we get -4 squared. Replacing y with +2, we get 2 squared. And the square of -4 is 16, plus the square of 2 is 4. And 4 plus 16 is 20. And to get r, we extract the root of both sides. The square root of r squared is r. And we take the square root of 20. 20 can be written as 4 multiplied by 5. And we can extract the root of 4. The square root of 4 is 2 multiplied by the square root of 5. Therefore, the radial coordinate of the point with this Cartesian coordinate r is given by 2 equals square root of 5. Now we find the angle theta using tangent. And using the tangent function theta, its value is equal to the ratio of ordinate over the abscissa, from which we obtain theta is equal to inverse tangent or arctangent or shift tangent of y over x. And replacing y with 2 and x with -4, theta is equal to shift tangent of -2 over 4, or that's -1/2. And we find the shift tangent of -2 over 4 by using our calculator. We have shift tangent of -2 over 4 or -1/2. And the answer from your calculator is, to 2 decimal places, you should get -26.57 degrees. Now we plot the point to check if this is the angular coordinate that we want. We plot the point -4, 2. That is the point with Cartesian coordinate negative 4, 2. Now, the angle theta is negative. The answer we get is negative 26.57. And this also is taken as an angle in standard position, which means that its origin, its vertex is at the point 0 or the origin. And the initial side is on the positive x-axis, but it's measured in, because it is negative, it's measured in clockwise direction. Now, to plot the radial coordinate, 2 times square root of 5, we approximate the value of 2 times square root of 5 using our calculator. We have 2 multiplied by square root of 5. That's 4.47. The value of the radial coordinate of the point to 2 decimal places is 4.47. In plotting the point with polar coordinates, we start with the angle and we get negative 26.57 degrees measured in clockwise direction from the positive x-axis. And from the origin, we now count 4.47 units. But if we do that, you will see that you will get a point different from the given point, negative 4 over 2. But we are plotting the same point only with different coordinates. The given point is in Cartesian coordinates, but we are plotting the same point only with polar coordinates. So how do we get the same point with polar coordinates? You extend this terminal side of the angle negative 26.57 to the opposite side. And the distance of this point from the origin is the radial coordinate of this point, 2 times square root of 5. Now we find the angular coordinate of this point. Instead of negative 26.57, we must write the positive angle in standard position measured from the positive x-axis to this side, to this line, this ray, opposite the terminal side of negative 26.57. And that angle is obtained by subtracting this line makes a straight angle of 180 degrees. And from this 180 degrees, we must subtract 26.57 degrees to get the angle from this point to this line. So we subtract 26.57 from 180. And you should get 153.43 degrees. Hence, the angle from the positive x up to this line, this ray, which is opposite the terminal side of negative 26.57 degrees, is 153.43 degrees. And this point has Cartesian coordinates negative 4, 2, with polar coordinates, and this same point has polar coordinates 2 times square root of 5 and 153.53 degrees. So this point with polar coordinates and this point with Cartesian coordinates and this point with polar coordinates represent the same point. This point in the second quadrant. We now answer number 2. We find the polar coordinates of the point with Cartesian coordinates negative 3, 2, where x now is negative 3 and y equals negative 2. The abscissa of the given point x is negative 3. The ordinate y of the given point is negative 2. And we want to find the polar coordinates of that point with radial coordinate r and angular coordinate theta. And we start with finding the radial coordinate of this point using Pythagorean theorem. The square of the radius vector is equal to the sum of the squares of the abscissa and the square of the ordinate. And we replace x with negative 3, we get negative 3 square. We replace y with negative 2, we get negative 2 square. And the square of negative 3 is positive 9. The square of negative 2 is positive 4. And 9 plus 4 is 13. Hence, the square of r is 13. And to get r, we take the square root of both sides. The square root of r squared is r equals the square root of 13. And we calculate the square root of 13 using our calculator to 2 decimal places. And you should get 3.61. For the square root of 13 to 2 decimal places. Now we find the angular coordinate of this point using the tangent function theta, from which we get theta is equal to shift tangent of y over x. And then we will plot the point to see if we have the correct angular coordinate. We now find the angular coordinate of the point negative 3, negative 2, using this formula to find the angle theta obtained from the tangent function of theta. Substituting the values of y and x, y is negative 2 and x equals negative 3. We have theta equals shift tangent or arctangent or inverse tangent of negative 2 over 3. And negative 2 divided by negative 3 is positive 2 over 3. And we calculate theta using our calculator. The mode of your calculator should be in degrees. We have shift tangent of 2 divided by 3. And to 2 decimal places, you should get 33.69 degrees. Now we plot the point -3 and -2 to check if this is the correct angular coordinate of the point negative with Cartesian coordinate -3, -2. The point -3, -2 is this point, the point in the third quadrant where the values of x and y are negative. Now we plot this angle. Theta is 33.69 taken as an angle in standard position, hence its vertex is at the origin and its initial side is on the positive x-axis, and we measure 33.69 from the positive x-axis in counterclockwise direction. And this is the angle 33.69 degrees with the terminal side, this ray from the pole or the origin. And when we plot a point with polar coordinates, after we measure the angle, we count r units from the origin. And r is 3.61 units. If we count from the origin 3.61 unit, you will not land at this point. You will get a point on the terminal side of 33.69. And that's a different point. That point does not have the Cartesian coordinates -3, -2. So what you do, you draw the extension of this terminal side of 33.69 degrees in the opposite direction. The distance now of this point from the origin is the radius vector r equals square root of 13. And the angle that we want is the angle measured from the positive x up to this ray on the opposite side of the terminal side of 33.69 degrees. And from the diagram, you can see that, again, this line makes a straight angle of 180 degrees. And to this straight angle, we add 33.69 degrees. And the sum is the angle from the positive x up to this line, or this ray, opposite the terminal side of 33.69 degrees. We add 180 degrees plus 33.69 degrees. and you should get 213.69 degrees. Hence, this point with Cartesian coordinates -3, -2 has polar coordinates equal to r square root of 13, and the angular coordinate is 213.69 degrees. (213.69 degrees) is the measure of the angle from the positive x-axis up to this point on the ray opposite the terminus side of the angle 33.69 degrees. And 213.69 is obtained by adding to 180 degrees, because this line makes a straight angle with measure of 180 degrees, and we add 33.69, we get 213.69 degrees. So when you plot this point with these polar coordinates, you start with 213.69 degrees, and this will be the terminal side of 213.69 degrees, and then you measure r units from the origin, square root of 13 or 3.61 units. From the origin, we measure 3.61 units or square root of 13 units. And you will land at this point with Cartesian coordinates -3, -2. We now take examples of finding the Cartesian coordinates of a point with the given polar coordinates. For our next examples, consider the following problems. Find the Cartesian coordinates of each point with the given polar coordinates. In number 1, the given point has polar coordinates -2, 60 degrees. And we find the Cartesian coordinates of this point. Again, the required is to find the Cartesian coordinates of this point with polar coordinates. That is, we find the value of x and the value of y, the abscissa and the ordinate. Given the radial coordinate of the point equals -2 and the angular coordinate of the point equals 60 degrees. And we start by finding x from the formula we obtained earlier using the cosine function. X is equal to r multiplied by cosine theta. From the formula we derived earlier using the cosine function of an angle, acute angle theta, x is equal to r times cosine theta. And we substitute the value of r equals -2 multiplied by cosine theta. And we replace theta with the given angular coordinate of the point 60 degrees. And we calculate -2 times cosine 60 degrees using our calculator. Cosine of 60 degrees is 1/2 or 0.5 and multiplied by -2. And you get -1. Next, you find the y coordinate or ordinate of the point with the given polar coordinates using the formula we derived earlier. from the sine function of acute angle theta, y is equal to r multiplied by sine theta. From the formula we derived earlier, y equals r multiplied by sine theta, and we replace r with negative 2 multiplied by sine theta, where theta is 60 degrees, and we calculate negative 2 multiplied by sine of 60 degrees using our calculator. Sine of 60 degrees is 0.8666. Multiply that by negative 2. And you round off to 2 decimal places, you get negative 1.73. Now we plot the point to see if our answers are correct. We plot the point with polar coordinates. R is negative 2 and theta is 60 degrees. And we take 60 degrees as angle standard position with vertex at the origin. And we measure 60 from the positive x-axis counterclockwise. And I will approximate 60 degrees. That is the angle 60 degrees. And from the origin, we count r units. But the given r is negative 2. That means we measure 2 units on the ray opposite the terminal side of 60 degrees. Because r is negative, extend this terminal side of 60 degrees on the opposite direction. And from the origin, you now count 2 units. And that is the point with the given polar coordinates negative 2 and 60 degrees. And this point has Cartesian coordinates negative 1 and negative 1.73. If you project that point on the horizontal axis, this should be negative 1. If you project this point to the vertical axis, that point should be negative 1.73. And this point has Cartesian coordinates negative 1, negative 1.73. So this point now is represented in 2 ways, as a point with polar coordinates negative 2, 60 degrees, and as a point with Cartesian coordinates negative 1 and negative 1.73. We now answer number 2. We find the Cartesian coordinates of this point with polar coordinates 5 and 5 pi over 4, where r now the radial coordinate of this point is 5. And the angular coordinate is theta, denoted by theta equals 5 pi over 4. We convert the given angle theta in radians to degrees. Again, the required is to find the Cartesian coordinates of this point with given polar coordinates. So we find the values of x and y. But first, we convert the angular coordinate in radians to degrees by taking pi equals 180 degrees. If pi is 180 degrees, multiplied by 5 and divide by 4. And we use our calculator. Multiply 180 by 5 and divide by 4. And you should get 225 degrees. We plot the point with polar coordinates 5 and 5 pi over 4, where the angular coordinate is equal in degrees to 225 degrees. And 225 degrees is taken as an angle in standard position. That is, its vertex is at the origin, and we measure 225 degrees from the positive x-axis counterclockwise. And that is the angle theta. We measure 225 degrees. From this point on the positive x-axis to this point on the negative x-axis, we have a straight angle of 180 degrees. And from 225, we subtract 180 and we get this 45 degrees. Thus, 180 plus 45 degrees from the negative x-axis to this point on the terminal side of 225 degrees is 225 degrees. And from the origin, we now count r units, which is equal to 5 units. Thus, this is the point with the given polar coordinates 5 and 5 pi over 4. We now find the Cartesian coordinates of this point with the given polar coordinates. For x, we use the formula derived from the cosine function of the acute angle theta. From the formula we derived earlier, x, the abscissa of this point, is given by r, the radius vector, multiplied by cosine theta. We replace r with 5, and cosine theta in degrees, 225 degrees. And we calculate 5 multiplied by cosine of 225 degrees using our calculator. Cosine of 225 degrees is negative 0.707 and multiply that by 5 before you round it off to 2 decimal places. And you should get negative 3.54 to 2 decimal places. We now find the value of y, the ordinate of this point with this given polar coordinates using the formula we derived earlier from the sine function of acute angle theta. Y equals r multiplied by sine theta. We replace r with 5 and theta in degrees is 225 degrees. So we calculate using our calculator 5 multiplied by sine of 225 degrees. Sine of 225 degrees is also equal to negative 0.707. And before you round that off to 2 decimal places, multiply that answer by 5, the value of r. And you should get negative 3.54 to 2 decimal places. Hence, the Cartesian coordinate of this point with these polar coordinates are negative 3.54 and negative 3.54. If you project this point to the horizontal axis or the negative x-axis, you get the value of x, negative 3.54. Also, if you project this point to the vertical axis or the negative y-axis, you get the value of the ordinate of this point y equals negative 3.54. Hence, this point has the given polar coordinates 5 pi divided by 4. And this same point has Cartesian coordinates negative 3.54 and negative 3.54. For your practice, please try the following exercises. Number 1, plot the points with the given polar coordinates. A, negative 365 degrees. B, 2 pi over 2. C, negative 1, 2 pi over 3. And letter D, 4, 7 pi over 4. The first coordinate is the radial coordinate, r. And the second coordinate is the angular coordinate denoted by theta. Number 2, find the polar coordinates of each point given with the Cartesian coordinates. Letter A, 2, negative 1. B, negative 5, 7. C, negative 8, negative 5. And number 3, find the Cartesian coordinates of each of the following points with the given polar coordinates. Letter A, 2, 3 pi over 4. B, negative 1, 125 degrees. And C, negative 3, 5 pi over 3. And that completes our introduction to polar coordinates. And if you have questions about the lesson today, please ask your questions in the comments below. Thank you for joining me in my class today in Calculus 3.